If you haven't heard of it before, Antennapalooza is an amateur radio event that provides a way for people from several clubs to get together for a whole weekend, not just for a couple of hours at a Hamfest sale. It usually takes place in a paddock at Drewin West, about 100 kilometres east of Melbourne. There's a large pavilion where some of the presentations take place. There's a campfire for the evenings. Visitors can put up their own antennas or just compare notes with their different projects and chill out for a few hours. This year, 2024, will be the 9th Antennapalooza event. There's usually a theme to each event, and on each day there'll be guest speakers on a topic, sometimes undercover, sometimes out in the open if more space is needed. In 2015, we erected an experimental rhombic antenna that was spread over several acres. This worked quite well, although the weather leading up to the event wasn't very kind. Some of the PVC poles had to be replaced after being hit with some really high winds. In 2024, we thought we'd try something different, something not for the average backyard. We wanted to put up a wire curtain array for 20 metres. This style of antenna is a group of dipoles that gets phased together. The original curtain arrays, like the Sturber curtains and the Bruce arrays, had 100-metre high towers and took a long time to build. Some of these designs go back for a century and weren't particularly efficient. A lot of antenna theory was still being developed back then. This image here shows a curtain array that was on 100-metre towers, and it would be massive and pretty hard to build, particularly that reflector grid. So we won't be doing that. Instead, we're going to try a more modest approach, something like this, which is just hand-drawn. There's 2 poles, 18 metres high, and spread 60 metres apart, with an arrangement of 8 dipoles, each with its own reflector, suspended by rope between the poles. At least that's the theory. Let's see how it happens. But we're going to need a lot of parts to make that work. I looked at lots of different designs, and because there was a limit to how high and how wide we could go with the time we had available, there appeared to be an advantage in using folded dipoles over straight dipoles, so we thought we'd go down that path. If you look at this picture again, I'm just highlighting where the reflector elements are for each folded dipole. The antenna had to go up fast and be built to a pretty low budget since it's only a temporary event. The first challenge is the fabrication of the 2 18-metre high support poles. We're going back to the PVC pipe model, but with some differences. We're going to go with 3 at a time, taped together and stacked to give us the extra strength that we need. The pipes come in 6-metre lengths, so if 3 are stacked and guyed vertically, then we get to the right height that we need of the 18-metre target. With the 3 stages of pipes, we're going to have to guide the posts at 3 different levels. This is a bit of a problem, so I worked with a local machine shop and we designed some guying plates on a CAD package. Then we cut them out on a CNC router in 6mm aluminium. It has the 3 large holes for the PVC pipe, 3 more holes for guying points, and a 4th one set to one side for a pulley to hoist up the antenna wires. I brought these plates back to our workshop, filed them up so that they didn't have any sharp edges, and they come up pretty good. It's a very tough alloy. I think it might be for the aviation industry, this particular alloy. Right, so that fits over here. It'll sit on the joining points of each section, slide down, and there's our guying points all in one go. The next step was a trip to Bunnings to buy 18 lengths of PVC pipe. These are usually around the $18 mark, which is not too bad. The 3 tall poles were going to need a lot of rope. It was off to eBay to buy most of a kilometre of cable hauling rope. As a permanent installation, this rope gets affected by the sun, but it should be okay for a couple of weeks with what we want to do. Another tricky point is where the ropes have to attach to the ground. regular pegs and star pickets aren't really good enough. They will pull out when the wind gets a bit rough. So I'm using these special pegs called ground grabbers. I'll just bring that a bit closer. That's about 450mm long with a hex head and screws through the topsoil into the clay, and they work quite well. And just to make sure, I'll be using these in pairs. Bring that in. So I put them through a bit of chain and actually tie the guy ropes to the chain so that the pegs will load share when they're in the ground. That seems to give a lot of sticking power. The next challenge was the spacers and balun plates for the 8 dipoles. A lot were going to be needed, and they had to be pretty tough to take the strain, yet easily adjusted in length because the exact length of these wires have yet to be determined. I'm really going to have to build this antenna to try and tune it. Using circuit board software, I developed these end sections for the dipoles to hold the ends at the right spacings, and a feed point with an SO239 socket and screw terminals for the wires. Building these out of circuit board material was going to save some time during assembly. The panels showed up 3 weeks later from my Chinese circuit board manufacturer, and they look pretty good. They come wrapped up like this. I'll open them up. Right. And we've got this arrangement. There's an SO239 goes in here. There's space for cable ties. There's space for screw terminals, and for a balun to go onto the back. I'm going to start with a 1-to-1 balun and go from there, just so that I know what the impedances are. And at this end of the folded dipole feed point, there's another anchor point for keeping the 200mm spacing between each leg of the folded dipole. So that's the feed point plate. These are the end plates where the folded dipole will come in through some strain relief holes, terminate on the screw terminal, and out again the other side with a big hole for some rope to attach. And these are just regular spacers to go in the dipole, because each dipole is going to be about 10 meters long, which is pretty long, and I don't want them twisting together. So I've got these generic little spacers to fit between and have a cable tie on each end. Here's one of the feed points put together. You can see the screw terminal blocks, and I've made a 1-to-1 balun on the back, and that should be good for a bit of power actually, because it's quite a large ferrite ring, a type 43 wound as a 1-to-1 balun with an SO239. Now, a lot of the curtain arrays have been built with open wire feeders, and they take a bit of setting up to get right. What I thought I would do on this occasion is make each dipole pair tune back to 50 ohms unbalanced. That allows me to couple the 4 pairs of dipoles together with a manifold feed system similar to what you do on VHF arrays. That should work. We'll find out. I should mention that this is also quite thick. Normal circuit board material is 1.6mm thick, but I had this cut at 3mm thick, and that would take a lot of breaking. They're pretty tough. They're also good in the sun. In the paddock, the first step's going to be to prepare where the posts are going to go and try and get those posts in the air. The location's marked out using Google Earth Maps so that we can get the right orientation for this array, hopefully pointing long path to Europe, which from southern Victoria, Australia, is not much different from the short path to Europe. But at least it's somewhere to get maximum advantage. At the time of day, we're likely to be using this system. The anchor points are marked out on the ground and the screws are inserted as far as they'll go. The ground here is becoming quite hard at this time of the year. An extra anchor is inserted at the base of each pole so that there's a point to tie off the antenna itself after they're raised in the air by rope. To form the radiators for the antenna, a lot of wire was needed. I settled on the 1.5 square mil stranded copper wire, which was plastic coated. I had a lot of it around the workshop, but I was going to need a lot more. I visited a local electrical engineering firm, and they had rolls of wire in different colours of the right size that they weren't really going to use again, and were happy to pass it on to me. So I added it all up and there was enough to build the antenna with what I had. All of this wire was rolled out and cut to size in the hallway with some whiteboard markings on the floor to make sure we had the right lengths. The upper dipoles were fed from the feed point of the lower dipoles via a half wavelength of open feeder with a half rotation phasing twist. After the wires were prepared, the dipoles were assembled and pegged out on the ground to ensure that the lengths were all consistent. When these were ready, it was time to peg out the guy points for each of the masts. All of the guy rope was rolled out on the ground and cut to size for each of the stages of each mast. There was a bit extra applied to each guy rope so that we could put truck hitches at the ends to maintain the right pressure at each point. Standing up the two masts was a tricky operation. It was too hard to stand the entire masts up in one go as the combined sections had a lot of flex. It was a bit like trying to build a radio mast out of oversized pasta. We decided to stand the first two sections up at the same time. Di, VK3JDI, was brave enough to simply grasp the pole from within the boom lift as it was being elevated above ground level. When it was held vertical, I could then run around and tension up the support ropes. The process went fairly smoothly. The pulleys and hoist cables were attached to the masts prior to standing them up so that they could be used later for hoisting the antenna itself into the air. Then came the tough step of adding the top section to each mast. It was difficult because the boom lift could only reach about 12 metres, the height of the first two sections. A special triangular clamp was added to the boom lift so that the top section could be grasped by its base, while volunteers on the guy ropes would keep it vertical during the lift. All this had to happen while threading a path through the existing ropes. Eventually, the top section was placed into position and socketed into the second stage. It took about half an hour to add the top section to each mast, but we've accelerated the process here for this video. Back at ground level, the ropes could be adjusted to supply full tension and to set the masts entirely vertical. She goes up a long way. The guy ropes are roughly every 60 degrees and the curtain array is in the centre. We've got aluminium spreaders to maintain the distance between the reflectors and the driven elements. Everything is still fairly close to the ground at the moment while we're setting up, so it's not at its operational height. The guy ropes behind each mast were doubled up into two thicknesses because once the full load of the antenna came on, the extra stress was going to be a bit much for a single rope, and we wanted to make sure that we could pour the tension on. When the antenna was finally attached to the two masts, 60 metres apart, one problem became apparent. When the tension was going to go on, there was a bit too much of a sag in the centre of the dipoles and wasn't going to be enough to just get away with two masts on their own. Ideally, we would have had a third mast in the centre. As this was a temporary installation, we cheated a little bit just by using the boom lift to elevate the centre of the dipoles and kept it that way for a couple of days until the event was over. What we've done is to put the boom lift in at the halfway mark, just to try and relieve the tension off the midpoint. There's about 1,100 metres of rope in this assembly. Each of the guy ropes come back to the same location on the ground. We've put these ground screws in pairs as mentioned earlier. There's one screw head there, another one there, coupled via a bit of chain, and that goes deep into the sub clay and it's pretty tough. The coax cables were cut to size, we crimped PL 259s on them, and the manifold system looked like it was going to work well. The total antenna impedance was down to about 60 ohms, and resonance was excellent in the centre of the 20 metre band. The SWR was a low 1.1 to 1, 1.2 to 1. There were two SWR dips around about 200 kilohertz apart. One dip was the resonance of the 8 dipoles, and the second dip we believe to be the halfway vertical coupling between the lower and the upper dipoles. DETA VK3FFB ran some modelling for the design using the same element spacings and wire types that we had used. The plots showed a projected forward gain of about 17.5 dBi with an excellent front to back ratio. The radiation angle was a low 25 degrees, and this was going to favour long skip distances in practice, but we were yet to find this out. This array is fed as a series of dipoles. They're in pairs, so it's one dipole above the other. The lower dipoles each have their own balun. In this case, it's a 1-to-1 balun. That couples to an RG58 coax and also couples to a vertical riser which goes up to the top. And collectively the two dipoles will lower the impedance. So this feed line, if we follow it, it goes into a T-piece for the second pair of antennas, and that goes into another feed line, and this one's a full wavelength of coax with velocity factor taken into consideration, and that goes to a third T-piece. And this third T-piece has a cable on it that goes to the transceiver. This area has been fenced off to prevent the cattle from getting in and perhaps chewing on the guy ropes. There's a report of some storms coming this evening which might have some damaging winds, so as a precaution I'm going to lower the array to the ground, and I'll add an extra rope from the pole back down to a ground guy point to provide a little bit of extra reinforcement. Hopefully it will withstand anything that's going to come up in the next 24 hours. We want this thing to survive for the event coming up this weekend. It was a particularly windy season. Gale force winds a few days later did drop one of the masts. This made a bit of a mess of rope and plastic, but with the application of PVC pipe joiners, some glue, the mast was repaired and erected once again. We lost about 400 mil of the shattered sections. I've got some height on the antenna, but it's hard to get much more without putting additional tension on the top dipoles. And I'm not sure that in the hot weather that these vertical posts will withstand the extra tension. Still, it's just high enough off the ground to get decent antenna measurements and to try it out as well. The original intention was to have the antenna up and working a week before the Antennapalooza event in December of 2024, then keep it there for about 2 weeks. Fate had other plans. On the approach to the big day, bad weather was forecast. 80km/h winds and 30 mil of rain were expected. Nobody was going to enjoy a field weekend under those conditions. So reluctantly we suspended the preparations and broadcast a deferral of the weekend till mid-January. This complicated matters because we had to lower the dipoles to the ground to preserve them and to nurse along the masts for an extra month that we hadn't anticipated. In January, the new date for Antennapalooza came around. The paddocks had all browned off in the meantime, and there was a lot of smoke haze in the air from fires that were burning in the Mornington Peninsula. It made for some pretty spectacular sunsets. A 3 metre by 3 metre tent was put up at the feed point to use as a shack. Then we were in business. We were receiving a lot of strong signals across the 20 metre band. There was wall-to-wall stations to be heard. Jordan VK3 ACU recorded this sequence in the CW section of the 20 metre band. Visitors could either use the FT950 on site or plug their own radios in and have some fun. We had some strong contacts both in Europe and some of the countries in between. We knew that some aspects of the antenna were always going to be concessions because it was simply a temporary installation. It would have been nice to allow for switching directions and employing maybe greater height, but that was outside our budget. Soon enough the cows were going to want their paddock back again. Some of our visitors brought their drones along and were able to obtain some excellent footage of the antenna from around the paddock. Thank you to Peter, VK3DEL, for supplying the images we can see here. On the Sunday, some storm clouds gathered. We could see on the weather radar that a savage storm front was approaching us in the afternoon. Visitors packed up their camps and we lowered the pavilion early when the last of the presentations was finished. The curtain array was just going to have to take its chances with the approaching storm. When the front hit, the horizontal wind pressure was incredible, gusting up to 90 kilometres per hour. Finally, one of the masts couldn't take it anymore and shattered into pieces. Geordie, VK3CLR, was fortunate enough to capture the event. Here is the demise of the mast again in slow motion. That collapse signalled the end of our grand experiment. It had been a fun project and we learned a lot from the process and a lot about the antenna performance. It was a great opportunity to visit the effectiveness of these giant wire broadcast antennas of the SDA. They're probably not a good option for the average backyard. It would have been nice to have more time to see how closely the performance matched the modelling prepared by DETA, but the weather gods had other plans for us on this occasion. Many thanks go out to Diane, VK3JDI, Jim, VK3UFO, and David, VK3XMF, for holding on to the guy ropes at critical times. Also thanks to Profile Engineering for fabricating the guy rope plates. A special thank you goes to the sponsors of the 2025 Antennapalooza event. That was the Gippsland Gate Radio and Electronics Club, the Eastern Mountain District Radio Club, Fan Park, the Frankston and Mornington Peninsula Amateur Radio Club, Spark, the Southern Peninsula Amateur Radio Club, the Pride Radio Group, and RASA, the Radio Amateur Society of Australia. This has been a pretty big project and it's taken a while to cover all of the details of this story. Tell us what you think of the video and leave your comments